Now we will consider expression for the centrifugal tension. Centrifugal tension. What this centrifugal tension is? Actually, when the belt continuously runs over the pulleys, when the belt continuously run over the pulley, there will be the development of the centrifugal forces, and this centrifugal force will try to push the belts away from the center of rotation, and this leads to the development of the centrifugal tension. Actually, the effect of this centrifugal tension, when the velocity of the belt is less than 10 meter per second, is negligible, but when it increases and it becomes more than 10 meter per second, it there is a considerable effect of the centrifugal tension on the belt. So how this centrifugal tension can be found out? Okay, so this centrifugal tension Tc is equal to m into v square. Centrifugal tension is given as Tc is equal to m into v square, where Tc is the centrifugal tension in newtons, m is the mass of the belt per unit length in kg. Now whatever the centrifugal force is being developed, and this centrifugal force is a function of mass of the belt, so it depends on the material of the belt, we can say, and v is the linear velocity of the belt in meter per second. When the centrifugal tension is taken into account, now whatever the total tension in the tight side, Tt1 is equal to T1 plus Tc. Now whatever the power transmission we have considered up till now, that is P is equal to T1 minus T2 into V. Now if we consider the centrifugal tension, now we have to adjust the T1 and T2 effects, and this the total tension will be Tt1 is equal to T1 plus Tc, and total tension in the slack side Tt2 is equal to T2 plus Tc. Now this particular factor Tc is included in the T1, and power transmitted, we can say power transmitted P is equal to Tt1, that is total tension, minus Tt2 into V. This Tt1 is nothing but T1 plus Tc minus Tt2 plus Tc into V. Okay, so if I consider this, and if I look at this particular expression, T1 plus Tc minus T2, this can be rewritten as T1 plus Tc minus T2 minus Tc into V. So here we are looking at that Tc, these two terms get cancelled, and then power transmitted P is equal to T1 minus T2 into V. This is same as our original expression. From this, what conclusion we can take? The centrifugal tension has no effect on the power transmitted, or though we consider the centrifugal tension in a belt drive, the total power transmitted does not change, and it will be P is equal to T1 minus T2 into V. The ratio of the driving tension may also be written as over here 2.3 log of Tt1 minus Tc, because T1 is nothing but T1 is equal to total tension, that is Tt1 minus Tc. So that term we included over here, and it will 2.3 Tt1 minus Tc divided by Tt2 minus Tc is equal to mu theta, where Tt1 is the maximum or total tension in the belt drive. So from this we came to know, that is, though there is no effect on the power transmitted because of the centrifugal tension, and it will remain same, but this centrifugal tension plays important role while designing a belt drive. Now we will see the expression for the maximum tension in the belt. maximum tension which the belt can sustain while transmitting the power. So maximum tension in the belt, which we are considering as a T, is equal to the total tension in the tight side of the belt drive, that is TT1. Whatever the maximum tension the belt can sustain, it will be always equal to, or we can say it will be the total tension in the tight side of the belt. When I say total tension, this total tension Tt1 is equal to T1 plus, if we consider the centrifugal tension, that is Tc. Let sigma is the maximum stress in the Newton per mm square, because whatever the maximum tension the belt can sustain, it depends on the maximum stress, and it thus we can say it depends on the what material we are using. B is the width of the belt in millimeter, and T is the thickness of the belt in millimeter. So we know the maximum tension in the belt, as we know, that is the stress sigma is equal to force upon cross sectional area, right? So force here is what? Force here is the tension in the belt. So we know the maximum tension in the belt, that is the maximum tension in the belt T is equal to maximum stress multiplied by cross sectional area of the belt, is equal to maximum stress is how much? Sigma. Sigma into cross sectional area is the width into thickness of the belt, and this we can call as a T is equal to sigma into B into T. When the centrifugal tension is neglected, then T is what? T, or total T, is equal to total tension is equal to T1, the tension in the tight side of the belt. And when the centrifugal tension is considered, then T, or Tt1, is equal to T1 plus Tc. So here whatever the maximum tension which can be developed in the belt drive is limited by the centrifugal force Tc. So we have to remember this particular formula. T, that is the maximum tension in the belt, is equal to sigma into B into T. Now we will consider the condition for maximum transmission of maximum power. The belt drive which can what is the condition for transmitting the maximum power? For the maximum power to be transmitted by the belt drive, the total tension, or we can say the maximum tension in the belt drive, is equal to thrice Tc, is equal to thrice Tc, where Tc is what? Centrifugal tension. Tc is centrifugal tension. So the for the maximum power, total tension in the belt drive is equal to thrice Tc. Thus we can say that when the power transmitted is maximum, 1/3 of the maximum tension is absorbed as a centrifugal tension. So in a belt drive, whenever the maximum forces are being transmitted, the tension developed in the tight side, which will be equal to Tt1 is equal to T1 plus Tc, and this maximum, if this is the maximum tension, then 1/3 of this Tt1 is equal to 1/3 of the maximum tension is a centrifugal tension. As we know, T1 is equal to T minus Tc, that is the tension T1 is equal to total tension or maximum tension minus centrifugal tension. So our maximum power Tc is equal to T by 3. So putting these particular values in this equation, T1 is equal to T minus T by 3 is equal to 2T by 3. From equation 1 we can say that T minus 3Tc is equal to 0. Okay, and as we know, T minus 3 into 3 mv square is equal to 0, because centrifugal tension is Tc is equal to mv square. as Tc is equal to mv square, and from this, for the maximum, the velocity of the bed for the maximum power transmitted is V is equal to under root T by 3m. So next term which we are going to see, that is called as an initial tension in the belt, right? So whenever we wound the belt on the pulleys, actually we try to firmly grip the belt on the pulleys. So though the belt pulleys are not rotating, the belt will be in some tension, and this is called as an initial tension in the belt, right? To increase the grip, the belt is tightened up on the pulleys. At this stage, when the pulleys are stationary, the belt is subjected to some tension. This is called as a initial tension. स्टार्टिंग में ही हम अगर उसको थोड़ा सा खींच के पुलिस पे लगाते हैं तो वो इनिशियल जो टेंशन रहेगा, दैट इज कॉल्ड एज एन इनिशियल टेंशन. Let T0 is the initial tension in the belt, and T1 and T2 are the tension in the tight side and the slack side. And mu and alpha is a coefficient of increase of the belt length per unit force. As we will pull the belt, there will be a certain increase in the belt length. A little consideration will show that the increase of tension in tight side is equal to T1 minus T0, and increase in the length of the belt and increase in the length of the belt on the tight side is equal to alpha into T1 minus T0. Similarly, decrease in the tension in the slack side is equal to T0 minus T2, and decrease in the length of the belt on the slack side is equal to T0 minus T2 into alpha. Assuming belt material is perfectly elastic, that is, whatever the increase in the length in the tight side is there, similarly there will be the decrease in length on the slack side. Thus we can say, we will equate these two relations, that is alpha into T1 minus T0 is equal to alpha into T0 minus T2. This tends to T1 minus T0 is equal to T0 minus T2. That is, initial tension T0 is equal to T1 plus T2 divided by 2, neglecting the centrifugal tension. And if we consider the centrifugal tension, then it will be equal to T1 plus T2 plus 2C divided by 2, considering the centrifugal tension. So these are the two expressions which we have to remember. These are the two expressions which we have to remember, that is T0 is equal to T1 plus T2 divided by 2, neglecting the centrifugal tension, and initial tension T0 is equal to T1 plus T2 plus twice Tc divided by 2, considering the centrifugal tension.